Welcome to the State Epidemiological Outcomes Workgroup webinar series on data familiarization. The series will cover 4 installments, 4 webinars. The first one, of course, is this one, What is Data? The second is Data Considerations in the SEOW's Context. And the third one is Working Examples from the Profile. The fourth one will be somewhat of a continuation and further dive into the profile, specific topics. And then the fifth webinar will be special topics and a wrap-up. The first 2 webinars, 1 and 2, will be pre-recorded, obviously like this one, the first one. The other 3 will be live in Zoom, and we're looking for good participation from that. Hope to see you there. So let's begin with Webinar 1, an introduction. What is data? And a little bit about myself. Obviously, my name is John Starkweather. I work at the University of North Dakota School of Medicine and Health Sciences. I've been here in North Dakota since August of 2019, and I'm still getting used to the weather, particularly the winters. So here we go. What is data? So just to give you an overview of how this webinar is going to progress, we're going to go through some common data source types, what those are, what they mean. Then we're going to cover some key terms or key items in terms of what is in data, what are some different types of variables and how they're defined, as well as a little bit about measurement. And then we're going to talk about some common file types and some advantages and disadvantages to each of those. And then finally, we'll conclude with some more key items or key terms, in particular, some special considerations regarding certain types of data that we utilize and some things to watch out for, with those special types. So data types can, somewhat generally speaking, fall into 2 categories. These are very commonly referred to as quantitative data and qualitative data. Now, quantitative data is typically more kind of objective, more precise, where we're focused on numbers or numerically measuring something. Whereas qualitative data is a little bit more subjective. You can think of things like anthropological studies or case studies where the investigator is observing something and recording their own interpretations or thoughts about what they're seeing, what they're observing. It's generally limited reliability and external validity, but it's very often the only type of data collection available for a specific thing being investigated. And so you see there on the slides, there's a couple of simple examples. So for instance, quantitative, say you want to know how tall I am in inches, you could use a tape measure and a straight edge and come out with 65.5 inches. That would be quantitatively assessing my height. Whereas a qualitative approach to that might be you see me from across the room, or you see me on Zoom and you look at me, my image or something, and try to interpret how tall I am. So you might characterize me as somewhat short, which I am. So, all right, what are some of the data source types we use for SEOW products? So we tend to stick with quantitative data. The data sources typically fall into 3 categories or types. So we have documents, we have dashboards or web widgets, and we have raw data. Now the documents are typically a PDF file we find online, or maybe a static HTML page, web page we come across that has information. Maybe we can pick up a fact sheet or a quote or something. Less often we come across Microsoft Word files, DOC or DOCX file extension. And I bring that up, it's not so frequent nowadays as much as it used to be. Now most folks convert any kind of Word or text document into a PDF because it's freeware and easily shareable. Of course, PDF stands for Portable Document Format. So mainly with documents, we're talking about text or tables. So some type of paragraph or a quote or something like that, or some type of table of information where we're looking at facts and figures and so on. And of course, we'll get more into that as we go along here. Dashboards or web widgets, on the other hand, are much more interactive, right? So rather than just going to a static HTML page, when you go to a dashboard or a web widget, you're going to be able to interact with that presentation to get down into the data more, to drill down. That's kind of a common phrase. And I'm sure most of us by now are familiar with the idea of dashboards, if for no other reason than because of COVID. Thanks, COVID. Now everyone's familiar with dashboards because of that, I would think. But at any rate, and then the third data source type we typically deal with, and this is the one myself I have the most experience with, is raw data. So in other words, we're talking about a particular file we would download and manipulate or do something with. But it's important to remember those aren't the only types of data source out there. Obviously, there are others, such as databases. You might have seen SQL databases, whether you're using the proprietary software SQL, which stands for SQL, or something more open source if you're on Linux or Unix, for example, where you have MySQL packages, things like that. And then, for those of us who are a slightly older vintage, you may remember punch cards from the old days of mainframe computers, as well as, paper output that you get, or somewhat more recently, Scantron or pencil and paper surveys and things like that. We don't typically see those much anymore. So those three basic types of document or data sources we typically interact with, and by we, I mean myself and my two colleagues who are going to be presenting these webinars, involves documents, dashboards, or web widgets, and then raw data. And we'll talk quite a bit about raw data throughout this webinar here, this presentation. So source type, let's talk about the documents. So like I said, these are typically static files. Okay, when we say documents, of course, in the old days, we would think paper, like maybe newspapers, journal articles, things like that. But nowadays, it's pretty much all digital, which I'm sure everyone can understand. They can be reports, summaries, tables, figures, graphs, or a combination of all of those. And many times they are a combination of all of those. The most common type of document we see is the PDF file. Like I said earlier, PDF is a kind of a open source format for a document file. Comes, of course, from Adobe, stands for Portable Document Format. And an example of that would be the North Dakota Division of Vital Records, their VES, or Vital Event Statistics. So that particular example shows different vital or life event kind of records for North Dakota, deaths, things like that, different types of death, and so on. And you can go to the website or the URL listed there to download. I think the most recent one now is 2021, should be up there. So, but you would just change the date in that URL and you can get to 2019, 2021, whatever, to get the particular vital event statistics file you want to look at. Some other ones might be a static HTML page. So just like a web page, like for instance, here we have the State of North Dakota Office of the State Tax Commissioner, where you can get taxable sales and purchase reports and things like that, which is particularly useful for something like tobacco tax, right? And so if you go to the North Dakota Tax Commissioner website, a lot of times they'll have like quick facts or something, some data nuggets is what I would probably call them on their static HTML homepage, or maybe they'll have a thing that says publications and you can download a document, or just look at the static HTML page you're presented with. And then other document types might be RTF. So RTF, people don't say this much anymore, but it stands for Rich Text Format. And this includes Microsoft Word documents, old format DOC file extension, or the newer versions, which are DOCX file extension. Like I said earlier, you don't see too many Word documents online anymore. It's mostly PDFs, but all of those are really just more complex formatted examples of rich text formatting. So if, for instance, you didn't have Microsoft Word on your computer, you would still be able to open those types of documents using pretty much any RTF editor. So if any of you are familiar with Linux, you probably know there's a variety of other software freely available to open, edit, manipulate those types of documents. But all right, data source type dashboard. As I said earlier, these are dynamic or interactive websites. So it's not just some static page you go to and view. You can actually go there and click on things and manipulate the display of data that you're presented with based on your own inputs. Now, the output of those inputs might be a single piece of information, or more often, it's a table or a graph of some kind. So for instance, you might have the entire distribution of grade point average for UND, and then you click on something that says, well, class standing, and you pick out sophomores, and then you would get just the distribution of grade point average for sophomores for a particular year, or maybe a 10-year average or something like that. So it's an interactive display where the user can manipulate what is going to be presented to them. Power BI, Microsoft product, of course, proprietary, fairly expensive, is the most common. So for instance, North Dakota Department of Health, their COVID dashboard is done with Power BI. Probably most people listening to my voice right now have been to that website at one point or another in the past 2 years, 2+ years, I should say. But there are alternatives. Tableau is also fairly popular, but there are other ones, Shiny and a few others. But it's basically any type of interactive data display that's available through a network. And it's important that I say through a network, because this could be something internal. It doesn't necessarily have to be publicly available on the World Wide Web. With a larger internet, it might be on an intranet localized to your organization, or it might be password protected to only certain folks within the organization. But the key is here with a dashboard, we're talking about something that is interactive, something where the user can manipulate what exists there, what they're presented with, to refine the resulting display. So that's dashboards. The next data source type, the one I'm probably most familiar with, is raw data. Now, these are files which are typically downloaded from the web or can be sent through email, sometimes requiring authentication, sometimes requiring a fee. So if we're talking about, for instance, licensing boards, right? So statewide licensing boards may require a fee. You might have to fill out a data request form. The raw data file might be sent to you in an encrypted form, so you have to de-encrypt it, or it might just be sent to you through postal mail or something like that. And these are necessary protections sometimes, because the data file might contain some sort of confidential information, particularly if we're talking about anything health related. You have to be careful with HIPAA and so on. So there are a wide variety of file formats used, and occasionally multiple formats are available. So for instance, sometimes you'll go to a particular website, like I have at the bottom here, the example of the Burfus, right? And so you might go to the Burfus website or one of the others and be presented with a choice of what type of file you want to download the data as. So we'll talk more about these later, but it's often not limited to one particular type of file that you're going to receive the data in. You can kind of choose which one is your favorite, which one you're most familiar with dealing with. But so generally, some form of code book or manual is necessary to utilize the data and understand what is included in the data. So code book or manual might be in a different format than the data itself, right? So the data file itself is kind of the raw nuts and bolts of information we're interested in. And then the code book or manual explains what that information or how that information was collected and or displayed in the data file itself. It's really kind of a definitions and explanations of what you're going to find in the data file. And of course, this will become more relevant as we go on and we talk about some other elements of what is data. So some of the key terms here. So, a lot of these key terms, most folks probably know from their, undergraduate training in terms of research methods. So at the risk of sounding redundant, I still want to go over some of this stuff because it is important to keep this in mind whenever you're talking about data. So when we talk about population in a research methods or data-centric conversation, we're talking about the entire set of units being investigated. Typically, in our case, particularly dealing with, the state epidemiological outcomes workgroup, we're talking about people, right? If we were all biologists, we might be talking about fish, we might be talking about nucleuses or cells or something like that. But the unit being investigated typically for us is people. But when we talk about the population, we must be very careful in how we define what it is we're investigating, okay? And so if we're interested in investigating, let's say just 10th graders in the Grand Forks Public School District attending the first day of class in fall 2022, that's pretty specific, right? It's not saying all 10th graders in Grand Forks because some of them might not be there the first day of class, right? We're being very specific about, okay, we want to investigate the 10th graders in Grand Forks Public School, not private schools, but the public schools, and only those who attended the first day of class. So we're being very careful in our population. And it's important to be careful in that definition of population because generally speaking, we do not have access in terms of research to every individual in the population. And that's true whether you're talking about fish or cells or nucleus or 10th graders, right? You're probably never going to get all 10th graders in Grand Forks Public School District for the fall semester because occasionally some of them are absent or halfway through that semester. Some are going to come in, some are going to drop out. People move away, move to Grand Forks. And so it's probably changing. So when we're talking about research and we're talking about a population, we have to be careful about how we define that. This is the thing, this population specifically is what we're researching. And so we have to be careful when we define that in a research context. The other reason why that's important, of course, is we're not going to get every individual member of the population, and that brings us, of course, to sample. The sample, in a research sense, is the subset of the population available or gathered for investigation, which provide the data on which we're basing our conclusions upon. So most of the data we deal with comes from samples, not entire populations. And it's important to understand, or at least have some understanding of, how that sample was gathered, right? Because if we're talking about a strict, hard science, experimental context, right? Controlled experiment, then we want to have, hopefully, in the best case scenario, a random sample. Okay. And now, random sample in this context, in a research, in a science context, random has that word random has a very specific meaning. It's not just, oh, we picked a few folks out from where they were lined up, and those folks we picked out, that was random. No, that's not random in the sense of science and statistics and research, right? Random really means each individual has an equal probability of being included. Okay. So a random sample means that every individual in the population has an equal chance to be chosen for that sample. Okay. This is where you get in old textbook discussions of using a random number generator and truly randomly picking. Okay. Like flipping a coin, heads or tails, 50-50, each side of the coin has an equal probability of coming up, assuming the coin is a fair coin, not somehow rigged. And then, of course, we have like a stratified random sample. And this is one that comes up fairly frequently for us when we think about looking at different aspects or characteristics of a population. So for instance, if we know that all 10th graders in Grand Forks Public School District are, 49% female and 51% male, then we're going to stratify our sample based upon that distribution. So instead of being 50-50 totally even, we're going to randomly sample, 49% of our sample is female and 51% is male, or whatever the characteristic is. It just means that you're going to sample based on some known characteristic of the population. And this relates to the next thing there, which is sampling weights. So you can do this a couple of different ways. You can sample, the number of individuals you pull based on some probability estimate of the population, or you can sample completely randomly, and then looking at how many males and females you have, you attach a weight to each, which reflects the known distribution in the population, right? And then, of course, we have their convenience sample. Convenience sample is decidedly not random. It's whoever you can get, given the practical constraints of this situation, right? So in a lot of research, the reason you can't sample the entire population of interest is because it's not economically feasible or practically feasible, right? So for instance, if you're interested in looking at all autistic students or students diagnosed with autism, it's very difficult to get participation in that type of research investigation, right? Parents are very cautious. It's difficult. And so you're not going to get the entire population. So you might only get a few, and it's based on self-selection, right? Selection bias. Excuse me. It's a convenience sample because only the parents willing to allow their children to participate in research are going to be part of your sample, right? All right, and then like I said earlier, sampling weights, weighting each sample unit based upon some known characteristic or characteristics of the population. So just to rehatch here, our population example was all 10th graders in the Grand Forks Public School District attending the first day of class for fall of 2022. So our sample might be 47 10th graders from Grand Forks Central High School and 38 10th graders from the Red River High School in Grand Forks. So our sample, therefore, is 85 10th graders. And then I have tacked on there kind of we typically use a mixture of formats whenever we produce some written content. But a lot of how we format is derived from APA formatting. And so what I have down here is the little italicized lowercase n equals 85. So the lowercase n italicized indicates a sample size of 85 individuals. Now, if we were talking about a population, we'd probably use a capital N italicized. But that's really just a stylistic thing. And that just happens to be the way APA formatting dictates that you do it. There's other formats, of course, things like MLA, which is Modern Language Association. There's also Chicago style, often used in journalism and so on and so forth. But typically, if you see lowercase italicized n equals some number, it's conveying to you some type of sample size or subsample size. All right, more key terms, key items, key terms. What is in raw data? Well, the simple answer, of course, is information, right? The nuggets of information. The more complex answer is data are generally digitally represented as a two-dimensional array. Now that's really kind of just a fancy way of saying rows and columns, right? So anyone familiar with Microsoft Excel, SPSS data editor, Open Office Calc, there's a variety of them. Basically, if you picture in your mind some type of spreadsheet, right, that's a two-dimensional array. It's rows and columns, okay? And each intersection of a row and a column is a cell, okay? And one of the keys here is each cell should only contain one piece of information. So within a two-dimensional array, rows and columns, we have rows and columns which are made up of cases and variables, which contain values and or value labels. So each case is the unit of investigation. So typically for us here with the SEOWs, COs, I know a lot of people are probably going to ding me because I say SEOWs, but at any rate, typically what we deal with is human beings, people. Those are typically our cases, our unit of investigation. And then the variables, which represent descriptive aspects of those individual cases. And those aspects can be expressed as either values and or value labels. And we'll get a little bit more into this as we go along, but really quickly, values are typically numbers, value labels are typically non-numeric. Okay, so what state are you in? Well, we're in North Dakota as opposed to Alabama, Arizona, etc. Values, what is your age in years? My particular age, I'm not going to say, but let's pretend it's 22. That would be a value, 22, indicating the number of years. Another thing we should probably discuss, because if you're going to deal with raw data, you're inevitably going to come across both types of shape with respect to raw data. Now, the two types of shape, obviously there on the slide, are wide and long. It's important to remember that some folks are more familiar and more comfortable dealing with wide, and some folks are more comfortable dealing with long. The key thing is you can flick between the two. Okay, there are several, no matter what type of software you're using, there's always a way to convert one to the other. So whatever your preference is, that's the one you should stick with if you're most familiar with. Wide is more common, and that's the one we're going to talk about both of them, but wide is more common. So here is the wide data shape. So the key characteristic of wide data, in other words, the way the data is arranged, is that you have one row per case with columns as variables to hold the values and value labels. Each case should have a unique identifier. And this is kind of a sticking point with me. Other folks might disagree, but if you get a data file and it does not have some sort of unique identifier for each case that is non-identifiable, then you should probably make a unique identifier for each case. So for instance, looking at the bottom of the slide here, we have an example data file. Notice that there are names in here. Now they're just first names, so it might not be easy to identify who these folks are. Of course, this is made up data, it's not real data, but for this example, once you get this data, you're probably not going to want to have people's names in there for a variety of reasons, HIPAA and so on, different confidentiality concerns, IRB concerns, but also because names could potentially bias you in how you deal with the data. Okay. Every one of us, every human being alive has bias. Okay. We have our preconceived notions. We may not recognize them, but they're always there. And so it's a good idea, at least from my perspective. And again, I should stress this is really kind of my opinion. When I get a data set like this, I would simply delete the names and put in, an ID. And often it's just a sequential number from 1 to the number of cases. That way I'm not biased or distracted, let's say, by the names being potentially identifiable as who they are. All right, so a case may be a person, a mouse, a rat, a tree, a cell nucleus, like I discussed earlier. It's the unit of analysis or investigation. So each unique identifier allows the case to be de-identified. Like I discussed, you can remove identifying information once you have this unique identifier or ID column or variable in the data. And so like we see here in our example, we have cases 1 through 4, and then we have some values and value labels, right? So the names, the class, junior, senior, sophomore, freshman, those are value labels because they're not numbers. Now, it's important to realize that just because you see a column of numbers doesn't necessarily mean that those numbers are values and not value labels, because value labels could be numbers as well. Typically, though, it's not going to be numbers if they are value labels. And then we have the height, the weight, time 1, time 2. Those are the variable names identifying the columns. Oftentimes, when you have a wide data shape, that first row of the variable names, that will often be called the header for the data file. And then you have the values and value labels within each cell. So that's an example of the wide data shape. Now, if we look at the long data shape, the key distinction here is each case has multiple rows. So we notice if we look at the right side of the slide, case ID number 1, right, has 5 rows. Each row defines a different variable. So each case has multiple rows, and each row defines some characteristic of that case, meaning some variable. So the first one for the first case is class. We see that that case is sophomore. The second row, second variable is height, the value being 72 for that particular case, whereas the second case, the height is 68 inches, right? And so the unique identifier still allows us to de-identify or anonymize, I guess, the data before we send it to someone else or do something else with it. So we see the key distinction here. Key distinction being the wide data shape. Each case has 1 row, and each column defines that case, particular characteristics. Whereas in the long data shape we have here, each case has multiple rows, and each row helps define that case. Variable types. Now, there are a lot of different ways to talk about different variable types, and you're going to see that as we go through the next few slides. But to start with, let's talk about some basic variable characteristics. Okay, and something else I should probably say here is when I say the word variable, that has a particular meaning. And what it means is that the values can fluctuate, right? So I once had a professor, he said, what do you call a variable where all the values are the same? And it kind of stumped all of us in the class. We're like, I don't know. And he kind of winked and chuckled. He's like, it's not a variable, it's a constant. So if you think back to basic mathematics and things like that, you know, a plus b times 2 plus z or something. Well, if a has all the same values, if it's just repeating the value 2.7, then it's a constant, right? Whereas a variable, a, would have multiple different values in it, right? So variable characteristics. Some variables are specifically named because of the characteristics they contain. And the big thing here is it continuous or not continuous? And even more of a caveat to that is it continuous, nearly continuous, or is it discrete, right? So a discrete or categorical variable has a limited or finite number of values. Now, I have it as an example here, gender, and gender might have 2 different values, might have 3 different values, might have 5 different values, but gender is not going to have 6,257 values, right? It's not going to have an infinite or nearly infinite number of values. Whereas a continuous or nearly continuous type of variable theoretically has an infinite number of possible values, right? Hundredths of a second reaction time. You might be phenomenal, and athletic, and amazing. Unlike me, you might be able to react in 0.002 hundredths of a second. Or like me, it might take you 6 or 7 seconds to react to something, right? The idea is that reaction time could take, theoretically anyway, an infinite number of possible values. Now, it's also important, caveat upon caveat forever here, it's often in the social sciences, we treat variables as though they are continuous when we know they're really not continuous, right? This is kind of a shortcut that's often taken in the social sciences and even in other sciences as well, where we know there isn't an infinite possible number of values, but we tend to treat a particular variable like it is. And you know, the classic example of this is the Likert scale. Now, I used to say Likert scale, and then I ran into a professor who corrected me because they had been a student of Likert, and they said, no, it's not Likert, it's Likert. But at any rate, just about everyone will recognize the idea of strongly agree, NA, disagree, strongly disagree. Okay, that's an example of a Likert scale. And you've seen a variety of different ways this can be done. And so we sometimes attribute numbers to those different values. Strongly agree is a 5, agree is a 4, and A in the middle is a 3, and so on and so forth. And we might treat those as continuous, even though we know they're not continuous. But it's a key distinction to know if a variable is discrete, categorical, has a finite known number of values versus not, whereas we have a continuous, which is theoretically infinite number of values. All right, the next variable type here. So variables are also classified by the content of what they express. This is often true in the context of statistical software, and I'll talk a little more about software packages later on, but software communicates or understands pretty strict ways of expressing things. Okay. And when it comes down to is basically numeric or non-numeric. So you have like numeric variables are expressed with numbers, meaning their values are numbers. So like age in years, rather than age in he's old, he's young, she's quite young, she's quite old, whatever. Which would be an example of a string or a character string. So here we're talking in the context of like programming, computers. What is the machine that sits in front of me? What does that characterize variables as, right? Regardless of what software you use, how does the software recognize the characteristics of a variable? And pretty strictly, it's going to be numeric or string or character string. String and character string are really synonymous. They're the same thing. But it's also important to realize that a lot of software within those two general categories of numeric or non-numeric, within those two general categories, you also have specialty values, right? So like currencies or dates, where you might have numbers expressing these things, but if you tell the software, hey, this is a specialty thing, this is a currency, then it understands, okay, I know that the denominations are this, or I know dates, there's only so many days in a particular month as opposed to another month that might have more days, leap year, etc. All right, so you can see how some of these might intermingle a little bit or overlap a little bit. But typically software is thinking numeric or non-numeric. And if it's non-numeric, it's probably going to be treated as character string, right? So think about like states, right? Alabama, Arizona, so on. So those are the different, content types, I guess you could say, or software understanding types.